Welcome back, folks, to Scripting for Linguists. In this episode, I have this question for us. When calculating lexical diversity, specifically the MTLD wrap algorithm, is it worth it to call rest from Python? MTLD stands for Measure of Textual Lexical Diversity. The wrap part of that name refers to wrapping around from the end of the text to the front of the text to finish up your last factor. If that's all Greek to you, just stick with me. I'm using the PyO3 Rust crate again. It allows Rust and Python to talk to each other, and it's awesome. It's been fun for me to learn how to use this crate to write little Rust functions and call them from within Python. So I'm going to use some code that my co-author, shout out to Scott, sent me, some Python code. Here it is. I've actually modified it a little bit to make it work for my purposes. Our purposes for a co-author paper. Anyway, the idea I want to get across to you is that there is a nested for loop within a larger for loop. The idea here is real quick with this particular lexical diversity measure is that you start with the first word and you add words until the number of unique words divided by the number of running words, that quotient goes below 0.72. And once it goes below 0.72, that's called TTR, type to token ratio. Once that goes below 0.72, you add 1 to your factor counter, and then you also add the number of words that it took to get up to that 0.72 TTR, type to token ratio. That's the MTLD wrap. And then once you get to the end of the text, you wrap around to the front to finish up your last factor. So not as super complex, but it's actually more complex. It's a more complex lexical diversity measure than other competing measures. So anyway, I have a nested for loop within a larger for loop there. I have some breaks here. Here's another for loop, some breaks there. And then the final thing is to simply divide the number of factors, the sum of the number of factors by the number of factors to end up with your MTLD wrap score. So that's that. And then again, like I mentioned, I'm using PyO3 to call Rust code, and I do that right here. I call this little module that I created in Rust called LexDiv operationalizations, and I call the one function I define over in a different file. Here we go. There's the other file. This is the lib.rs file in my package, and I basically translated that Python code into Rust here, and I'm proud of myself because I did it by myself. Although I had to Google like nearly every line of code in Rust to actually make it work, I made it work. And it actually gave me the exact same result that my Python code was giving. So I felt pretty good. I later called my son, who is a computer science major, and he's a Rust master. He's really good. And I showed him my Rust code and said, hey, what would you do different? He's like, oh, I do this a little bit differently. I put this in here. And so I kind of modified it according to what my son told me how he would have done it. But the end result is I created it and it worked. So anyway, it's the same idea. I passed in my Python list of strings into Rust as a vector of strings, and then I create a hash set there on line 10, and then anyway, I don't go through all this. It's the same. It's just a translation of what I did in Python over there with some breaks here and there, right, to break out of it. And once you get to a TTR reading of 0.72 there, okay. And then you do this simple division down here at the bottom to get your actual MTLD wraparound score. Good. So we don't need to look at that too closely. I'll leave a link in the description of this video to both my Python and Rust functions here. Yeah, I've already run it before the video started, kept track of the times, wrote them out to a CSV file so I could put them into our old friend R. And here we are in R. Let's go ahead and take a look at... First, let's take a look at everything, and then we'll take a look at, we'll zoom in a bit. Let's take a look at this plot. So here's a plot of the times that it took Rust and Python to do the task according to the number of words. So on the x-axis, I have the number of words in the text, and on the y-axis, I have the number of seconds it took either Rust or Python to work. The green dots are Python, the red dots are Rust. Rust runs there. Okay, so let's actually zoom in a bit there. That was kind of zoomed out. There was two outliers way above, and they were causing the plot to scrunch down. So anyway, take a look here. We are seeing, yeah, a bunch of green dots, much higher than the red dots. Again, green being Python, red being Rust. So again, Rust is quicker than Python. That's the overall trend there. I want to turn off the dots so we can just look at those trend lines. Let's turn off those dots and look at that again. So yeah, we're seeing this is just, these are called the low S lines. That's a locally based smoother line that goes through the dots. Yeah, we're seeing that the green line Python is higher than the red line Rust. But down here in the bottom left corner of my plot, we see that at some point, Python is actually quicker down there. So let's zoom in on that area like this. And what do we see here? Well, we see that at about 70 seconds, about 68, give or take, somewhere in there, if you have 70 words, not seconds, excuse me, 70 words in a text file or fewer, Python is actually quicker than Rust, right down in there. But if you have 70 or more words in your file, Rust is quicker. Now, I assume that's happening because there is some overhead of having Python call Rust. And it has to pass a list from Python into a vector in Rust. There's some overhead there. I assume that's why we're seeing this crossover where at a point to the left of that crossover, Python is quicker than Rust, but to the right, Rust is actually quicker. So yeah, the take-home message is if you have few words in your text, Python's a little bit is quicker. But if you have more than 70 give or take words in a text, Rust will be quicker. It's worth it. It's worth the overhead to call Rust if you have 70 or more words in your text, because Rust takes off and goes quicker, and you make up the time that you lost with the overhead of passing it in to Rust. So to answer our question back here, when calculating lexical diversity, specifically this particular algorithm, which is probably, I'm going to say, one of the best algorithms, if not the best algorithm right now, MTLD wrap. Is it worth it to call Rust from Python? I'm going to say yes. Yes, it is worth it. Again, there is a little point right here at about 70 words or fewer where Python was actually quicker, but by and large, let's zoom out again. By and large, Rust is going to be quicker once you're past that little that point where Rust takes over Python and is much quicker from there on out. So again, I am loving learning Rust and figuring out how to integrate Rust into my Python code to make it quicker. Great. If you like this video, give it a thumbs up. And don't forget to leave a comment, subscribe, all that good stuff. Thanks so much. See you next time.